This is the largest space telescope in the world. This is the most powerful space telescope in the world. This is the coolest space telescope in the world. Well, I guess that would be the James Webb Space Telescope. Most of us have heard of Hubble or Webb. However, there are many other telescopes that are also amazing. In this episode of What If, we'll look at some of the other cool telescopes in operation or under construction today. Square Kilometre Array. If you like your telescopes big, then the Square Kilometre Array is the one for you. It's currently under construction in South Africa and Australia, with 197 antennas spread across a large area. Once complete, it will have a collecting area of nearly 2 kilometers squared, or about half a square mile. That makes it more than 3 times larger than any other radio telescope in the world. The largest single dish antenna is the 300-meter Arecibo radio telescope in Puerto Rico. What is ESKI? The Square Kilometre Array is not a single telescope, but an array of 197 smaller ones. These are spread out over 86 different stations. Each station contains 6 smaller antennas grouped together. They are then linked together with superconducting cables to form one gigantic brain. This means that the entire array can work together to form a single dish the size of the entire array. When will it be operational? The first phase of the project was completed in 2021, while they won't be fully operational until 2024. Astronomers are already using the 51 dishes which have been built in South Africa. What will it do? SKA is optimized for radio astronomy. Radio waves have much longer wavelengths than visible light. This allows them to see things that are invisible at other wavelengths, such as the centers of galaxies. It'll also be able to measure things much further away than what's possible with optical wavelength telescopes. For example, measuring things related to the Big Bang or looking for signs of life in other planetary systems. It isn't just radio waves that it can detect. However, thanks to its enormous size, it will also be sensitive to X-rays and even gamma rays. It'll be able to image black holes and neutron stars in incredible detail. The Extremely Large Telescope. This will be the largest optical wavelength telescope in the world. At present, the largest optical wavelength telescope is the 30-meter behemoth, currently under construction on top of a dormant volcano in northern Chile. It's called the Extremely Large Telescope, or ELT. How big is it? The main mirror is 39 meters in diameter. It's made up of 7 smaller hexagonal segments. They're each 1.5 meters across and weigh 215 kilograms. When will it be ready? The telescope itself is almost complete, but the entire project won't be finished until 2026. There's still lots to do, such as testing the huge mirror and making sure everything works properly. There's also a dome that needs to be constructed along with various buildings and infrastructure. What will it do? Thanks to its massive light collecting area, it'll be able to measure details on objects in space that have never been seen before. We'll be able to study the atmospheres of exoplanets in great detail. We may be able to actually image biosignatures in the future. Other cool things it'll be able to do is detect supernova and study dark energy. It should also be able to see things within our solar system, including Pluto and other Kuiper Belt objects. Do I yet worry if you thought that the ELT was going to take away Hubble's title of largest telescope? The ELT is designed to work with Hubble. There are plans for a new instrument module that can be attached to the aging telescope, giving it new life. The 30-meter telescope, another giant optical wavelength telescope that's currently under construction, is the 30-meter telescope like the ELT. It's also being built atop a dormant volcano, Mauna Kea in Hawaii. Why build so many telescopes on top of volcanoes? The reason is twofold. First, they're usually high up in altitude. This means that the atmosphere is thinner, which causes less distortion when observing celestial objects. Second, the ground beneath them tends to be very stable. Earthquakes are rare, and the rock strata helps block out unwanted vibrations. How big will the TMT be? As its name suggests, it will have a 30-meter primary mirror made up of 492 hexagonal segments. Each segment has a diameter of 1.4 meters. When will it be built? The project is expected to be completed by 2028. What will it do? Its mirror is smaller than that of the ELT, but it will make up for this with its location. The TMT will be closer to the equator than the ELT. This means that it'll be able to observe more of the sky throughout the year. Being closer to the equator also means that it can easily track targets to the west as the Earth rotates. This will allow it to do things such as measure the expansion of the universe, search for biosignatures on planets orbiting nearby stars, and image things in the solar system in infrared. Giant Magellan Telescope. Yet another large optical wavelength telescope is the Giant Magellan Telescope. This one will be built in northern Chile at the same site where the ELT is being built. Why is it needed? The GIM2 will measure details of objects in space that have never been seen before. Some of these things include mapping the distribution of matter in the universe, imaging the atmospheres of distant exoplanets, and directly imaging the formation of planets around other stars. It will also be able to determine the age of the universe with incredible accuracy. What makes the GMT unique is that it will have 49 individual mirrors arranged in a circular formation. The largest mirror will be 7 meters in diameter. All of the mirrors will be made of a glass ceramic called polycrystalline diamond. Why use diamond? Diamond is unusual in that it's a material that expands when exposed to heat. Most materials expand when heated, but metals contract. Diamond retains its shape and doesn't degrade over time, making it ideal for use in space. The GMT won't be operational until 2029 at the earliest. Overwhelmingly, all of these large telescopes are being built in northern Chile. This is due to a combination of factors. The skies over northern Chile are incredibly clear, thanks to the dry air and lack of light pollution. The sites are also high in altitude, which results in less atmospheric distortion. Finally, the sites are politically stable, and there's plenty of water around to keep the telescopes cool. Scientists hope to use it to detect things that are too small to be detected by current particle accelerators, such as new particles or new forces of nature. It could also help us learn more about the Higgs boson, which gives other particles their mass. Do we need another particle accelerator? You might be thinking that we already have the Large Hadron Collider. Why do we need another one? The LHC was instrumental in helping us discover the Higgs boson, but it wasn't able to detect dark matter, which is thought to make up a quarter of the entire universe. Dark matter is one of the reasons scientists want to build the LCI. Another is to look for signs of extra dimensions. String theory predicts the existence of extra spatial dimensions, but we have no evidence that they exist. The LCI could help us find them. What would you like to use these telescopes for? Let me know in the comment section down below. Also, don't forget to subscribe for more fun science videos.